Picture a packed stadium, a tied match, and the clock hitting the 89th minute. The manager makes a desperate substitution, but instead of a rising academy star, a dinosaur steps onto the pitch. A standard 6-foot human defender would be looking straight up at the knees of a large predatory theropod, completely dwarfed by an animal stretching over 40 feet from snout to tail. For over a century, the prevailing scientific consensus would have benched this creature immediately. Paleontologists used to classify dinosaurs as cold-blooded, tail-dragging reptiles, essentially just overgrown, sluggish lizards. Under that old framework, an animal of that size trying to run a fast break would overheat in minutes. And as for following the offside rule, a giant lizard lacks the brainpower to comprehend a ball, let alone team strategy. But the fossil record has forced a complete rewrite of that model. We now know dinosaurs were sophisticated, highly active animals built on the exact biological foundations required for sustained, high-energy movement. So if we treat the Mesozoic era as a scouting combine, we can look at the data to see which species actually had the biomechanics, the stamina, and the cognitive processing power to play a full 90 minutes. Any decent forward needs bipedal speed and the ability to cut and change direction instantly. Unlike modern crocodiles, whose legs splay out to the sides in a sprawling posture, dinosaurs had an erect stance. Their limbs were positioned directly beneath their bodies, structurally supporting their immense weight for upright running. To evaluate their footwork, we use fossilized trackways as our game tape. Look at this continuous path of preserved footprints baked into the prehistoric mud. This graphic breaks down the mechanics of those impressions. By measuring the stride length and the physical spacing between these 3-toed theropod footprints, we can calculate exactly how fast the animal was moving and when it accelerated. The math confirms that these 2-legged theropods were naturally engineered to execute the sudden stops and explosive sprints required on a modern football pitch. Speed alone isn't enough. A player needs the aerobic stamina and thermal regulation to survive a full 90-minute match. This immediately eliminates the giant sauropods. Moving a 50-ton body generates massive friction and internal heat, meaning a massive herbivore like Patagotitan would overheat and collapse after inevitably crushing the turf. Instead, we have to look at the active theropods, who relied on a high-performance cardiovascular system to sustain their aggressive lifestyles. In this T-Rex anatomy cutaway, notice a respiratory system similar to modern birds. Blue air sacs acted as bellows, pumping air continuously. Moving fresh air during inhalation and exhalation provided constant oxygen, functioning as an internal cooling system flushing out heat. This supercharged breathing apparatus gave these dinosaurs a distinct metabolic advantage, granting them the endurance to outwork almost any mammalian athlete on the field. Finally, we have to assess football IQ. A player needs tactical intelligence, spatial awareness, and the ability to coordinate with the rest of the squad. You wouldn't want a stegosaurus anchoring your midfield. Relative to its elephant-sized body, it had one of the smallest brains of any dinosaur, leaving it poorly equipped for complex strategy. Paleontologists evaluate cognitive complexity using the encephalization quotient, measuring brain size relative to the body. In this fossilized T-Rex skull, notice the sheer volume available for brain tissue. Scans reveal top predators possessed chimpanzee-level intelligence, ranking them significantly higher than dogs. This intelligence translated directly to behavior. As shown here, fossil trackways prove predators moved in packs, maintaining spacing and coordinating attacks against large herbivores. They understood social positioning, assigned roles, and group tactics, giving them the exact cognitive hardware required to execute complex set pieces and on-field strategies. Taking all the data into account, our absolute first-round draft pick has to be the Maniraptorans, specifically the highly agile Dromaeosaurs. Their scouting report is flawless: perfect bipedal balance, a high-stamina respiratory system, and an expanded forebrain built specifically for complex, three-dimensional navigation. Looking at their lower anatomy, there is an obvious foul. They possessed a specialized, oversized hooked claw on their foot. A firm strike would instantly puncture the match ball, and a slide tackle would pose a severe hazard to the referee. But even with a high probability of drawing a red card, these animals were biologically engineered for the specific physical and mental demands of the sport. The speed, stamina, and intelligence that would make them lethal on a football pitch are the exact evolutionary traits that allowed dinosaurs to successfully dominate life on land for over 140 million years. And technically, their descendants do still show up for matches. You see them every time a pigeon or a seagull lands on the stadium grass.